Okay, so before we start, you are not in trouble. I'm not calling you to the principal's office. I'm not accusing you of a felony. We just need to address the elephant in the room here, the dead corpse that is rotting and we can all smell it, so let's just talk about it. I went way too ham on this tutorial. It's something like 40-something minutes. That being said, it is a very good and useful tutorial, so proceed, forwards, but with a shitload of caution. The math gets a bit heavy here, especially if you're not used to this kind of thing. AP Calculus is essentially kindergarten compared to what we're about to do. So get your popcorn, but then kind of set it aside because you're going to need to put all your focus directly on the video. If you're going to be chewing, you're going to be hearing that thing and it's going to be distracting you. I'm not saying that this is like the hardest tutorial you've ever followed, but maybe among the top 3. No, actually no, it's probably the hardest tutorial you ever followed. Enjoy, hope you like it. See ya. Some tutorials are easy, some tutorials are medium, and some tutorials, like this one, aren't going to be tutorials at all because this is a massacre. It is a slaughter. I do not expect anybody watching this, including you, to survive all the way to the end. Some people are better at torture than others. They can withstand it for longer, and maybe you're that kind of person. But rest assured, I'm going to take out the scalpel. I'm going to take out the hammer as we get through more and more nodes, and by the end, you're going to be begging, please stop. I don't care about this QR code thing anymore, and at that point I'll know my job is done. Okay, so what is it that I'm going to be making in this project? Well, we have a QR code, which you might be thinking, okay, it's a QR code, it's a bunch of blocks, but wait a second, there's a very significant plot twist, and that is that this is all a procedural material, meaning that I can bring some sliders around, and you can see that it's updating in more ways than one. It's not just generating new patterns, but it's keeping these corner blocks where they're supposed to be in this kind of identifier block, which we're going to talk about. It's updating the position of that, so this is kind of like the resolution. This is something we can control. Another thing is, I don't remember what this one does. This is, I guess, is just the sliding of this, which works again with the slider. We also have a seed. We also have a bias, etc. And in this torture, again, this is not a tutorial, but in this, military grade torture of you guys, there's going to be quite a bit of nodes. So the whole thing was a node group that is also consistent of more node groups. And in some of these node groups, I think it's this one, there's even more, and it goes all the way down. There's so many math nodes, and I know what you're thinking. Wow. Yeah, it looks pretty complicated, is probably what you're thinking. And it's interesting that you thought that, because that is absolutely true. So let's get into how to make this. I swear, this is going to be hard. If you're thinking, maybe he can explain it slower, I'm going to. It's just not going to help. So before we make our QR code, just a bit of theory, so we're on the same page. Here are a bunch of pictures of QR codes. Google Images is an amazing thing. You could look up a picture of anything. You could even look up a picture of torture, which maybe not a good idea. That's a demonetization request right there. Either way, here are a bunch of QR codes. They're all different. I don't know if any of these work. Maybe some of these take you to foreign websites. Maybe some of these take you to like meatspin.com. I don't know. But one thing you are going to notice that all of these have in common is these corner panels, which is something that we're going to need to add. And then also this identifier little thing in the corner. You're going to notice that a lot of these have that in common, although some of them don't even have that block. But that's kind of like the black sheep. So somehow we need to generate this pattern with corners, with the thing. And I guess let's do it. So step 1 is creating the geometry before it is that we make... Wow, speaking English is very difficult. First thing we're going to do is make geometry before we even make the procedural material. And this is probably the easiest part of the tutorial. So what you need to do is add in a plane. You're done. Basically, we're just going to be using a material on this, where this is this is all the geometry we're going to need, because why would you need anything more than a plane? So pat yourself on the back. You've graduated, not even kindergarten. Maybe this is conception. Maybe your mom's pregnant now with the baby. That's the level of difficulty we're at right now. Next step is doing the material, and that's pretty much the rest of the tutorial. I'm going to take you to term. Hopefully your mom wants to keep you. Anyways, let's make a material. We're going to call this QR code, because that's what this is, and let's save our valuable progress, which, we can call it that, valuable progress. Okay, name of the game is we're going to put a bunch of nodes here and then connect it to the material output surface. Again, this is going to be pretty rudimentary to begin with. This is what we're going to be visualizing. We want to put a bunch of nodes here going to the surface and have them be the correct combination of nodes that gives us a QR code. So let's start with something basic. How do we make the black and white tile texture? An easy way to do this without image textures, again, we want this to be procedural, is use white noise. What white noise does, if we have some kind of texture coordinates, I'm just going to use a texture coordinates node, use generated coordinates, pretty much for this entire tutorial, although I might use object coordinates at some point. What this does is it creates TV static. You're watching Cartoon Network, it's 7 p.m., it's about to be dinner, it's the Avatar finale, and boom, the TV's turned off because, it's time to go to dinner and your mom hates you. This is TV static. It's white noise. It's infinitesimally resolution-y. There's a lot of detail. No matter how much you zoom in, there's going to be more noise. That's a good thing, although we want this to generate numbers between 0 and 1 like it's doing, but for discrete tiles, not like at infinitesimally many points or infinitely many points. A trick to do this is we're going to use vector math. So again, texture coordinates is a vector, and we're just going to be manipulating it with vector math nodes. By the way, turn back now if you're not ready for some math, or maybe just pay attention because that's how you learn things. You need to challenge yourself to get better. What we're going to do is, first of all, we are going to scale this. So we took our generated coordinates and now we're scaling it by some value, which is basically going to make the vector going in the same direction, but with a larger magnitude. And I'm just going to set up a value node so we can control this outside. The next thing we're going to do is add in another vector math to this chain. That is hard to say. And we are going to set this to ceiling. What ceiling does is it's going to take this input vector and round the x, y, and z components. Again, this is a three-dimensional kind of idea. It's going to round them up to the nearest integer. It's ceiling. It goes up to the nearest integer component y. So we have generated coordinates, we scale them, and then we take ceiling, which is going to give us a single vector, and the larger the scale is, the more kind of inputs we get in here, because again, instead of going from 0 to 1 on x and on y, now we're going from 0 to, I guess, 8.4 on x and y, which means when we do our rounding, there are 8 or 9. It's hard to think about it. I think 8 integers you can round up to. Think about that. It does make sense. But when we take this and plug it into white noise, now it gives us kind of a discrete system where every tile has a single value between 0 and 1. Again, the reason this works is generated coordinates is a continuum, whereas we made this discrete, so each tile is only one vector, so of course each tile is going to have the same value. Okay, so we can just control this procedurally, and one thing to consider is we probably don't want half tiles, as you can see here, so math node set this to ceiling. You're probably seeing a bit of a there's a word for this. I hate it when it's on the tip of your tongue, and you just can't quite taste what that word is. There's a bit of a theme. That's it. Of course I couldn't remember that word. 5 letters. So hard. Bit of a theme going on here with ceiling. This is going to make it so that every value I input in here is rounded up to the nearest integer so that we get a integer number of tiles on x and y. Okay? Cool. And you can kind of see how already this gives us our QR code setup. But just to kind of finish this out, I'm going to add in a math node, set this to greater than 0.5 is a fine value. In other words, we're taking this kind of discrete, again, this is discrete kind of grid or array of 0 and 1 values, and we're saying the ones that are bigger than 0.5, greater than or equal to, make them white, in other words, and for everything that isn't that, make it black. So we're kind of doing a bit of maybe segregation isn't the typical word you might use for this, but in some sense that is what it is, where we're splitting them into left and right groups, each of them equal, but some of them larger than 0.5, some of them less than 0.5. And again, this is all procedural. At this point, we can add in a couple more sliders, and at this point, I'm going to start speeding up a bit because, we're playing a Sonic Hero game, and I've been taking it easy. Wow, I've been taking it easy on you, playing Tails, sometimes playing Knuckles, whereas we should be playing Sonic and going fast, much faster than this. I'm changing the white noise to be 4-dimensional so that we have a seed value that is the W slider, the 4th dimension. Who would have thought that Blender lets you do 4th dimension stuff? This is just going to let us kind of change the seed and get different results. Doesn't really matter what this value is. And then finally, we are going to add in a bias slider. Again, this is for the greater than. you want to set this to 0.5 unless you want it to be all white, or I guess all black. If you're saying something has to be greater than 1, nothing will satisfy that condition, and if it's 0, the other way around, right? So that's just a bias. We're probably not going to play with that. So we already have a good start, and before we start doing the corners and everything, let's just kind of set up things nicely. I'm thinking 35 or maybe 25 or maybe 30. Just meet me halfway in the middle. Rock in a hard place. I'm going to choose the half rock, half hard place situation. Just so we have more tiles, okay? And now the next step is we kind of take this, and all we have to do, and this is kind of the nice thing about the QR code, all we need to do is just say, take this randomness and say we want something very definitive, something we choose in the top left, top right, bottom left corners, not this one, and then that kind of indicator thing. Again, just to remind you, these corner things, right? And then the indicator. And if you think about it, you're thinking, wow, that seems pretty complicated. I need to set down all these black tiles and white tiles. No, not really. I mean, what this really is, and this is the case for all of these, is you kind of have a black square, and then above it you have a white square and a black square, and it alternates. In other words, if we could kind of make an algorithm to make squares and have them alternate, then we are good to go. And that is exactly what we are going to do. Okay, so how do we make squares and an algorithm that makes squares that we can alternate? Well, slow down. Let's first of all go full screen so we can actually see what we're doing here. What I'm going to do this, and yes, there's probably a vector math way to do this, but I like to separate by components because sometimes it's easier to take a big problem and separate it down into little problems. Didn't your math teacher teach you that in 7th grade or 1st grade? I don't even know. Maybe up till 6th grade, they're like, do it the hard fucking way. And then in 7th grade, they're like, you know what? Maybe separate it into easy tasks. Maybe we should revolutionize the American education system. Point is, vector math would probably do this. I'm going to separate it by components, okay? So we have x-axis, 0 to 1, left to right, y-axis, 0 to 1, up and down, and z-axis, who gives a fuck, right? So how do we turn this into a square? I'm going to use a math operation, specifically the compare node. A little history lesson here. This little math operation was added in 2.82. Before that didn't exist, and this is a kind of nice way to combine greater than and less than and a bunch of stuff in a nice, convenient way. The way this works is it takes an inputs like the x coordinates, for example, and what we're doing is we are comparing the x to the second value. So we're saying how close is x to, in this case, 0.5 or 0.6 or whatever, and we're saying look at these two values, compare them, and say use this threshold. And okay, I'm making a mess of this. We're comparing 1 to 2 within this distance, this threshold, this kind of discriminator, right? So if we make this bigger, you can see this is exactly what happens. In other words, we're saying which x values are within this distance, this radius, this kind of magnitude away from the second value. So that's what comparing does. If this is bigger, it's wider. If it's smaller, it's smaller, okay? And then we could do the same thing for y. Point is, if you take x and y independently and multiply them together, in other words, take some from the left, take some from the right, and combine them together, well, once you increase this, you can see we get a procedural rectangle system, again, because we are combining this kind of bar with this one using multiplication, so of course we get a rectangle. Now in this case, we're doing QR codes, so it's kind of all square. It's hip to be square, not rectangle, so I'm going to use the same value as our radius in some sense for x and y. So you can see now we have a procedural square set up where, this is going to be the radius, the size, the magnitude, the ganas, the desire of this square. Stand and Deliver is a great movie. If you haven't seen it, go watch it. It's very topical with all this math and the education system and all that. What were we talking about? I think we were saying that now we have a procedural square system, but we don't want this to be any square size. No. In fact, we want this to match our QR code. So I'm just going to mix these together temporarily. So both are being kind of overlaid on top of each other with this mixing factor, right? So I'm going to keep it at 0.5 so they're equally transparent. We don't want this, first of all, to be in the middle. It needs to be in the corners, and we're going to talk about that in a second. But it should also be kind of the size of these tiles. Otherwise, it's kind of cutting through a tile, and it doesn't look too good, or at least be a integer multiple of a tile. A nice way to do this, and this is where it might get a bit complicated. So first of all, let's do some color coding. This is kind of the most important slider. It's the resolution, the size, how many tiles we have on X and Y, right? I'm going to take this, hit and enable color, and just color code it a bit just so we can spot it when we're zoomed out. Because believe me, soon we're going to be adding quite a few nodes. This might be the confusing part because we don't want this to be arbitrary. It needs to be based on this value node, okay? So in fact, we want it to be, if this is in this case 30 tiles across, this square should be 1/30th the size, right? So if it's 1, it takes up the whole thing. A 30th, it's only a single tile of these 30. So if it was 25, we'd want it to be a 25th, a 30, a 30th, etc. So to do that, I'm going to add in a math node, and we want to take the reciprocal. So division 1 divided by this number. So the reciprocal 1 divided by this. And I swear there was a reciprocal operation here. And even if there is, who cares? Because you could just do 1 divided by that. I'm going to put this in here. So again, this is the threshold or the comparison value for A versus B that we were talking about. And you can see that this kind of gives us what we want, although this is kind of the radius of 1 over, in this case, what is it? 1 over 30, it's not the diameter. In other words, it's kind of the thickness, the size of 2 tiles. So we could just, instead of 1 over this, we could do 0.5. And now it's the size of a single tile. Again, think about why that is. Basically, we're taking the center point and going 1 over 30 across. But if you do that in both directions, it's twice as thick, okay? Yeah, it's getting confusing. I get it, whatever. Okay, so now if you just put in 0.5, it's the right size. But it's kind of in between tiles, and we want it to be in the corner and all that. So how do we do it? Well, if you think about it, since we are comparing to the second value, this is kind of the X translation. This is going to be the Y translation. And if we set this to 1, it's going to put itself in the corner. But then we also have to, again, since it's using the center point to be at the top right corner, we need to do a bit of adjustment. And yeah, it really is a pain. So let me just do that. We're going to do a subtraction 1 minus this value, which again is the size that we want. So you'll see what this does in just a second. Put this in here, put this in here, and now you see the tile is exactly where it's supposed to be. You can see we slide it around, and since we have X and Y dependent on the same value, it's going to be going nice and diagonally, which in this case is actually a good thing, okay? So what do we have? Now we have a setup that lets us decide kind of the position of the square tile, and we can also decide the thickness of it. And this is really all we need to create the, again, alternating black and white kind of situation, okay? So let's talk about how to do that. First of all, what I'm going to do is I'm going to not center it on the top right tile like we have right now very nicely, but we are going to bring this a couple tiles inwards, like inwards over here, so that we can then grow out the corner. And one thing that you might notice is we have 1 minus kind of like the radius of this. So if we were to multiply this, multiply it by some number, so again, we're multiplying it by some number before we do the subtraction and all that, the correction term. If you were to put in integers, I think odd integers in this case, so 3, 5, 7, it's going tile by tile by tile downwards, bottom left perfectly. The reason this works is, again, when this is set to 1, we have the correction by half a tile. Again, if you set this to 0, it's like this. We have the correction term, and each time we bump this up by an integer, it's correcting by another half tile. So half a tile, half a tile, half a tile, half a tile. Don't you just love it when you do that little belittling, demeaning explanation? But point is, because it's half a tile each time, we want to keep it on odd numbers, so we're going by 2 half a tiles each time, okay? So now we have a system for that, and in fact, we can make that a little value slider that we put out here. And we could put a little ceiling on this so we don't go fractions of a thing, but I'm sure that somebody could put in a correct value, so we're not going to do that. We have that, and then we also have, again, we have kind of the size, which you are going to notice not only changes the size of our tile, but also shifts it down, because again, it's dependent on this, and we've created a mess. So what we want to do is add another multiply over here. So this is for the chain that's going for the threshold, and wow, this is a mess. But if we were, again, to use integer numbers, I think, again, odd numbers for pretty much the same reason, now we have a size boost. So 5, 7, etc. So when we have this set to 3, I think we're going to have black, and then we're going to grow by 1. We're going to have white and black. And I think because of that, we should probably go down an extra one just so we go, again, so we start with black and then white and then black and then white. So we need to transition 1, 2, 3 times. So we want to make sure we're sufficiently deep inside our tile to do that. So again, we start off with this being black, and then white, and you just have to imagine this, use your imagination here, and then black, and then white, etc. Okay, so let's also add in a nice little value slider for that. Okay, perfect. So now we have these two little value nodes controlling our square situation, and you're thinking, okay, we need to make it alternate, and then we need to make it even messier, right? We need to put it in the other two corners. Kind of don't worry about it. I can tell that your blood pressure is rising. It's kind of like a natural Viagra, but it's Blender knowledge, right? Just calm down, okay? We're going to take it a step at a time. First of all, let's deal with the alternation kind of situation we have going on here. Alternation situation, we're going to hibernate, and I ran out of rhymes. What we want to do is kind of take the setup minus these two value nodes that we want to control like after the fact and make this into its own node group so we could repeat it again and again and again. To do that, I'm going to highlight all of these nodes, Control G to group them, and then if we hit Tab, we can go in and out of this group or just hit this thing right here. And now we have a nice little node group. We can actually get rid of these value nodes and put this in manually. So again, this should be 9. This is the translation, and this is 3, the thickness. Now we have a nice little node group that does a couple things. First of all, it looks at our texture coordinates, so it's going to be dependent on these same generated coordinates. Second of all, it's going to update. I guess we should be using the ceiling function instead of just plugging this in directly, so let's just do that. So it considers, whoops, what did I just do? I just messed it up. We want to plug this in here and eliminate that. Point is, what I was trying to say is that this updates to the R value, which is kind of nice. Right now it's a bit messy because of this factor situation. It's a little hard to see, so let me do it like that. This updates to our tile, so it's kind of getting thinner, proportionate to our QR code resolution. You understand what's going on here. It does that, and then we can also shift it, whatever. I don't know what the point was. The point is, now we want to turn this into an alternating pattern. So we can just duplicate this whole setup. I'm just going to create some extra reroutes, so that's shift, right click, drag to do that. Again, if you don't have Node Wrangler at this point, what are you doing? We've gone pretty deep into the torture. I feel like we're doing the fingernail stuff now because we're getting meticulous. Go to add-ons, go to Node Wrangler if you haven't, make sure that's enabled, okay? So shift, right click, drag. I'm going to connect this to this, pretty much the same thing from before, but this time, for this one, what we are going to do is just make it a bit thicker, so 5. Still centered at the same point, we don't want to shift it, but like that. And I'm just going to do that 2 more times, so let's do the same kind of situation where we hook this up in the same way, and after we do this, we can actually move these reroutes a bit closer so we can see what we are doing. So we have our reroutes for coordinates, and then for, I forget what this one is, I think it's a correction term. This one we want to be 7. Again, we're going up by odd numbers, and I know this is very hard to grasp, but whatever. Point is, we have a square, and then a bigger one, and then a bigger one, and then a bigger one going up by 1 tile radius per, which is all relative to kind of this thing going on over here, okay? And now to make this alternating, all we have to do is kind of take this, subtract away this one, and then add this one back in and subtract. It's kind of like a target. Imagine that you're going bow and arrowing. We have the bigger one, which goes into the smaller circle, et cetera, et cetera, et cetera, until we hit the bullseye, the target, the whole point of this tutorial. What we're going to do this is add in a math node. So we take this and subtract away. We take this and subtract away the next smallest one, kind of like those Russian dolls that are nested inside each other. Then we add back in this one. You get the point. You can see how genius I am for setting it up just like this. You're welcome. Now we have a nice alternating setup that works with any resolution. Okay, cool. To get this to be kind of overlaid on top of here without doing any factor nonsense, first of all, make sure this is what is being seen. So we are mixing our QR code thing that, again, we could control with the bias and all this. We're taking that and we are mixing it with our corner pattern using the mix node, but instead of doing it something like this, we want to say take this kind of design and say use this, override everything we have going on here, right? Override it with the size of the biggest tile. In other words, if we are within this kind of mask, do our design. And of course, we can just take this, use it as the factor, bada bing, bada boom, now you have this thing in the corner. And I know what you're thinking, default cube, kill me. Okay, just fucking kill me. I don't want to duplicate all this and put it in the top left corner and the bottom left and all that. And I hear you. You don't want to take this. You don't want to make it a node group and like duplicate it a bunch of times. It wouldn't even be that bad, but I get it, right? It's a lot of work. And luckily, I do have a bit of a solution for you, okay? So one thing you are going to notice is the way we have this set up is it's all dependent on a single kind of coordinate system, right? It's all being fed in through this reroute node. It's all dependent on this generated coordinates. So what we can do is just a bit of a manipulation that kind of saves us, not kind of, it really does save us a bunch of time. So here's what we are going to do. The first thing we are going to do is just kind of, it's going to seem unmotivated, but just follow me. What I'm going to do is I'm first of all going to kind of translate this coordinate system just so it kind of looks like our, and let me just view this, it kind of looks like our object coordinates that are centered is the idea, okay? To do this, what we are going to do is add x and y by, make sure this is viewed so we can see what's going on. I think we subtract, we subtract, or add rather, a negative 0.5. And you can also do this on the z-axis, although everything we are doing is on x and y, okay? So we've taken our coordinate system and we did a bit of a shifting, okay? The next step, and this is the big trick, is we are going to add in an absolute value right here. And this is what it looks like. So in other words, what we've done is we've taken this coordinate system with the 4 quadrants. So here we have positive x and y values. Here we have negative x values, because again, here we have 0, the origin, and we're going left. Here we have a negative xy quadrant and a negative y quadrant. We took all of these, use an absolute value that does it on every component. In other words, we've taken this quadrant, the top right, and made it all of the quadrants. And we can kind of see what this does over here since it's already connected to the chain, and I'm interested to see what that does. It's kind of hard to see so far because what we need to do is translate everything back, and you'll see the motivation for this in a second. We are going to do another one of these adding situations, but this time do the reverse. And just like magic, really, and I'll explain this in a second, but just like magic, we've somehow created 4 of the alternating patterns without adding extra node groups. Why is this the case? The reason this is happening is our coordinate system from the beginning was generated coordinates. Forget the blue, forget the z-axis, right? We had x starting at 0 at the bottom left corner, going to 1, and same thing with y. So we have this in the corner. What we did is we shifted this down, so now the origin is in the center, not the corner, so we shifted it. We did an absolute value, in other words, saying each quadrant, again, is going to be the same because we took our x and y and did an absolute value point-wise, or I guess component-wise. So each quadrant you can think of as kind of like a piece of this generated coordinates, and then if we shift everything back down, it's kind of hard to see kind of with this setup, but you can imagine this kind of corner idea that we had in the beginning is now accurate, but for all, it now applies for each of these quadrants. So we've taken this generated coordinates and somehow split it into 4 different generated coordinates. If you don't understand it, well, neither do I, but it works, right? And because the thing worked before, if we just do a texture coordinate manipulation, it's going to work like this. Now, one thing I hear you saying, I hear you yelling, you're on the rooftops, hoping that I can hear. You got your megaphone, and you're afraid that I won't hear. What you're trying to tell me is that we should not have this on the bottom right corner, and you make a persuasive argument. You know, how can I argue with that? You're right, this shouldn't be in the corner. In fact, and I'm tired of going back to Google Images. In fact, we should have this here, if anything at all, not this corner design, okay? And you're thinking, okay, we have this absolute value trick. Surely there's some way to do this absolute value, but only do it for 3 quadrants, not the 4th. And to that I say, yeah, but we could do it in a much easier way without thinking about that kind of stuff. So back to kind of basics. What we're going to do to fix this is we want to isolate using separate x, y, z. We want to isolate the bottom right quadrant and say, hey, Blender, kind of take this node group that, again, we're using as the factor that we then do the alternating stuff. But really, we're using this as the mixing factor. We want to take this and say, take this design and remove the bottom right corner. How do we do that? Well, first of all, it's separate by x, y, z. We are going to add in, again, this is x component, y component. Who cares about the z component? Go home. Nobody cares. We're going to add in a math node. This time we're going to set it to greater than. We're going to do the same thing. And by the way, if you're seeing kind of this analogy, this kind of tale as old as time, as Homer wrote it about this kind of compare node versus greater than nodes. If you're seeing that similarity good, because it does exist. We're separating X and Y components, and you can see how this kind of isolates a quadrant by itself. Let's switch this to less than, so we have the bottom thing here. We kind of do the same thing as before with this multiplication, and that gives us the bottom right quadrant again, because we've said, look at the X coordinates going from 0 to 1, tell me where it's greater than 0.5, that's the right side. For the Y, do the same thing, but now from 0 to 1, tell me where it's less than 0.5. And then we multiply these kind of two ideas together. That isolates this quadrant. We can now take this, that is going to be our factor. We can take this, do a bit of a subtraction. So we are going to take our design and subtract away the quadrant. Okay? And no matter what we do with this value slider, which again, because everything's procedural, it kind of updates these. No matter what we do, it shouldn't cross the bottom right quadrant, so it's fine that this isn't actually dependent on that. In other words, we've created this nice little factor that we want to connect over here. And this kind of gives us the setup. And by kind of, I'm discrediting myself, because really what I did here is a big deal. So big, I'm gonna actually need to drink some water. Hold up. Nothing like not editing a tutorial so people have to wait for me to drink water. What we did here is use the absolute value setup, which puts this in all four corners, but then we said take away the bottom right quadrant. So now, long story short, at the end of all that, we kind of have this thing that scales and does the whole thing. It's pretty cool, and everything works, okay? So now, let's take this whole mess and kind of never look at it again. So I'm just going to select all the nodes that have anything to do with this kind of thing we have going on. So these, and then also these as well that we used for the bottom right quadrant. Control G to group them, and wow, that's already looking nicer, although looks like I missed that reroute node. So select that too, Control G. So now we have this nice little setup. So we have this kind of, I need to stop saying kind of, we have this design that is the underlying QR code. This is the randomness. We have the corners that we have filtered to only be 3 of them. We mix these together, and now the final step, which is going to be pretty similar to making the corners, although we're not going to have to do some texture coordinate stuff, right? The final step is adding that little identifier in the bottom right corner. I have the hiccups from that water and from talking so much. You're going to see that this indicator does look a little bit different. There's the same kind of alternating idea. This time, it doesn't start with this thickness of pixels. It's like 3 by 3. Here it starts with a single one, and then it expands, and then it expands only 3 times. So black, white, black, starting at a single one. Let's just do that and call it a day, okay? You know what? I was saying in the beginning that this would be torture for you and that you wouldn't be able to stand it. Plot twist, you're the torture. I'm the one being tortured because I'm the one who has to endure this. I'm the one who kind of has to produce the information. You guys can just sit back, relax. It's handed to you. Everything's handed to you on a silver spoon, but not for me. For me, it's a pain. I just have to explain this. That's my punishment. I bet there's a circle of hell just for this. Okay, so how do we do this final idea? Let's kind of speed run this. We're going to do the same thing as before. Sure, we could kind of extract a node group from here, but I don't want to kind of correct it and fix all this. So we are just going to make it from scratch. What we are going to do, kind of like the final hurrah, is we are going to separate, like we have 1,000 times, x, y, z of the generated coordinates. We are going to use this to, again, create that little center tile. So you already know the operation for this. So math, compare, you already know the story. I don't need to go through it step by step. Just make sure that you kind of get the ideas of, again, why I'm multiplying this x and y together. We take these independent ideas and combine them. I'm going to use a value node so that we have a square in terms of radius. And again, it looks like this, right? So we're comparing x and y to the center point, 0.5, 0.5 on generated coordinates. That's going to be the origin, 0.5, 0.5, or rather the origin of the plane. And we're saying, look at these values and compare them with this threshold, this kind of discriminator, etc. Okay? We don't want it to be any value. Again, we want it to be dependent on, say it with me, guys, we want it to be dependent on this value slider, the resolution, right? We want the reciprocal 1 divided by this, which we plug in, which again is kind of 2 by 2, if I remember correctly. So we want it to be 0.5. Now we have a single tile. Just to make sure, now we can mix this this tile on top of our previous mixture. So we're kind of stacking mixes on top of each other. The recipe continues. You can see we have this tile right here, whereas before it was 2 by 2. Now it's 1 by 1. And now we just need to shift it. And because it's going to be in the bottom right, we just want to set it all the way to the right on X, that is 1, and then all the way down on Y, which in generated coordinates is 0. We are then going to do the correction, which in this case, we need to increase Y by a 1/35th, or maybe a 1/2/35th. I think that's what we need to do. So you can just plug this in directly. Now you can see it's up here. And for the X, we need to do 1 minus this. In other words, we're just going to add in a subtraction. Let's put it over here. Subtraction, 1 minus that. And this is what we're going to compare to. So now we have this perfectly in the corner, and we can do a similar setup as before, kind of scaling this. Or I guess not scaling it in terms of size, but just in terms of position, so that it goes further up top left, okay? To do this, what we need to do is let's do a multiplication. So again, we are doing 1 minus a multiplication of, and let's set this to 1, of this kind of tile size. So we can increase this by odd numbers. And again, odd numbers because we're going by half a tile each time. So you can see exactly what that does. And it does seem to be offset a little. And that's interesting. We'll get back to why that happens. And let's think about it. Okay, so the reason that happens, I love doing tutorials live. The reason that happens is we're using the value node directly, not the rounding that we had set up before. Let's get rid of that. Now it should be working perfectly with odd numbers. You can see it's shifting down, and then we are going to do the same thing, but for the addition. And what do we have going on here? I think we just plug this in directly. Let's see if that does it. I think it does. We're going to add in a value node just to check. Boom. So now we can kind of control, and by kind of I mean exactly, the XY coordinates. Let's do a ceiling. Guys, I'm so tired. I'm so tired. Let this end. I don't even know how long we've been going for. It seems like we want this to be, is it even numbers or odd numbers? 3, 5, 7. Looks like we need even numbers. And then we have this thickness, which again is dependent on the, it's dependent on the thing. What we're gonna do to make this separate from everything else is, let's put this right here, just so it's a exact copy of what we have before, but this is what's feeding into the size. In other words, this just controls the scale without being part of the adjustment. Let's add in another value node for this, right there. So when it's 0.5, it has a thickness of 1. When it's 2, or is it 1? Can't remember exactly what it's supposed to be. What gives us a 3 by 3? I need more water. So it should be 3. So 0.5 times 3 is 1.5, gives us a 3 by 3. 0.5 times 5, 2.5 gives us a 5 by 5, etc. In other words, let's just simplify this a bit. We are going to multiply 0.5, whoops. We're going to multiply 0.5 by this integer, so we have 1 by 1, 3 by 3, 5 by 5. That's just an easy way to think about it. And just like last time where we did the alternating thing, now that we have this procedural setup, we're just going to set it up exactly the same way. So let's just kind of highlight all of these nodes that are relevant. I think it's just these, Control G to group them. And wow, I've created a mess. I think we need to do some rerouting before we do that. I think it's because I selected this. I don't want to do that. Let's try that again. We are just going to select these nodes, Control G. Is that a little less messy? Yes. In other words, this is just our square that we can control a bunch of stuff. Let it end. Just let it end. We're going to have a 1 by 1 tile, 9 down. This will be black, and then we're going to do the same thing as before. So let's create 3 iterations this time. Again, because it's going to start with black, and then white, and then black for our kind of identifier in the corner. Let's add in our reroutes for these, just so we can connect them the same way. This goes here, boom. No, I think it goes 1 more down, and then 1 more down. If only there's a way to automate proceduralism. I know the proceduralism is the automation, but we need AI to write the AI, long story short. Get us to the singularity so I can have Blender itself make QR codes for me. Let's just adjust these values. So this one's going to have a thickness of 3 by 3. This one's going to have 5 by 5. And then we are going to do the same thing as before. So I'm trying to remember. It starts with black and then white and then black. So instead of doing that, let's just do the opposite. We'll do an inversion later. So we start with this. We are going to subtract away this one, which kind of does the alternating thing. And then we are going to add alternation, also has alternation and subtraction in addition to create it. Now we have this. If we were to invert it, now we have the black, white, black, and of course we're not going to mix this everywhere. So finally, let's view this mixing. We want to mix our inverted image, in other words, the indicator. We want to mix that, but not everywhere, only wherever our largest kind of bounding box is. So use this as the, just let it connect, as the factor. There we go. So what do we have now? Now we have a setup that, and let's add in a value node just for that tiny little bit of proceduralism. So this was set to 9. This lets us control the position based on odd numbers. Of course, we can make this kind of a bit nicer. You know, maybe instead of putting in the odd numbers directly, we could put in a smaller number like 1, 2, 3. And then what's an odd number? It's something multiplied by 2 plus 1. Let's do it like that. In other words, it's an even number offsetted by 1. Luckily, there's this multiply add. Multiply by 2, add 1. That's easy. So 2, 3, 4, 5. Now we have a nice way to control this. And just in case the user is dumb and puts in something they're not supposed to, put in ceiling. Okay, so now we have the sliding situation. And let's put this over here since we want to keep control of that. And I do believe that is it. So we can take everything else, group it in its own node. And you know what? What the fuck? Let's just group it all. I don't care. Boom. We've created quite a mess. And I'm seeing quite a bit of generated nodes. Let's just fix that before we're done. Reroute, put that in there. Group. Group it. Okay, what do we have? What's our final result? So now we have this QR node that we put in our texture coordinates. In this case, it only uses 1 generated coordinates. That's kind of nice. Let's just Control H so it's not so visible. We have this master slider that, again, adjusts everything perfectly. So these corners adjust, the indicators adjust, the pattern adjusts. It's perfect. We have, what's this one? This one's the seed. This one is bias. This one is just the movement of this, which updates with everything else. Dear God, have we really done it? Have we created a QR code generator? I think we have. Okay, boom. I could talk a bit more about this and do the flourishes and make it nice, but quite frankly, I really am tired. I think I'm going to wrap this one up. So if you enjoyed this tutorial and you want access to exclusive tutorial stuff that I post only on Patreon and not, free on YouTube, well, of course, the place to do that or to get those is via Patreon. Additionally, you get access to Discord, the private voice channel and text channel. You get Discord access, project files like this one, so you don't have to make all these nodes yourself. Believe me, maybe getting the project file for this one might be the right idea. You got that, behind the scenes, etc. But really, it is the best way to keep CG Matter and Default Cube afloat because sponsorships and all this aren't reliable. So crowdfunding from the very people who kind of benefit from these tutorials is kind of the way to go. But if you're not interested in that but just want exclusive tutorials and benefits, like you're paying for something that exists as well, I want to thank all 500-ish, if not 500 plus patrons that I actively have. You guys are the fucking kings. I appreciate everything you do. And I think I can finally hang up my hat, kind of slump in my chair, and go off to like a 3-day nap and hope that nobody bothers me. Imagine ending a tutorial with a voice crack. Goddamn. Thank you for watching. See ya.